Hello my dear friends. So here I am with the practical demonstration of Ostwald's dilution law. I will explain you the theory behind this particular experiment. Now we go into the practical demonstration of this. As you all know, this is an instrumentation experiment where the instrument used is a conductor meter. Always remember my dear friends, whenever you start with the experiment, the first job is to put on the instrument. Okay, and your instrument is on. That's the first thing you need to do. And then you have to start up with your preparation of the solutions and etc. So that it needs at least 10 to 15 minutes, alright, to give you an accurate stabilized readings. Now the instrument, as I said, is going to be a conductor meter. The second point, and that is, once the instrument gets stabilized, you need to go for its standardization. Make sure that before you actually start with the readings, your instrument that is being under consideration is standardized. So here we have a conductor meter. There is a standardization knob which you can see over here, and you can see this, there is an arrow over here. Okay, so it has to be on the downward mode, and see this, it shows 1.000. So this is a very clear indication that this instrument is standardized, and now you can take the readings on this particular instrument. Now while taking the readings, first of all let me tell you, this is a conductor meter cell. This is a beaker containing a conductivity water. As I had already mentioned in the theory part, that during conductor meter experiments we are going to make use of conductivity water. So the electrode has to be placed in the conductivity water, and it should be in a downward mode, and it should show 1. So this is standardization. Alright, so I hope the standardization part of this instrument is very clear to all. Now when you have to take the readings, what we need to do is we have to lift it up this way. This should be the mode while taking the readings. Alright. Now next step my dear friends is about determination of cell constant. So for determination of cell constant, as I said earlier also, that the knob has to be on the upper side because the standardization is already done. Now this is a beaker which is containing 0.1 normal KCl. We are going to introduce the electrode into this. Alright, so as a result of which, the bottom portion of the parallel plates of the electrode will dip into the solution, and it is going to, you can now see the reading, it's 12.88. Of course this has to be multiplied by 10 raised to minus of 3. Alright, so this is the conductance of KCl solution, 0.1 normal KCl.
Done.
Alright, so now we go into step number 3. How step number 3? The first step is, I shown you how to standardize the conductor meter. Step number 2, determination of cell constant by making use of 0.1 normal KCl. Now the third, one of the most important steps of this particular experiment is preparation of solution. Yes my dear friends, if you prepare the solutions very well, then this experiment is absolutely simple. Alright, so please have a complete watch of it. We have 0.1 normal acetic acid whose dissociation constant has to be determined. It's a weak acid, and you know Ostwald dilution law is applicable only for a weak acid. Now what I've done is I've taken 4 beakers and I have labeled it so that there is no chance of any mixing of the solutions. So we have 0.1, 0.05, 0.025 and 0.0125. These are the various concentrations. Now the given concentration, you can see it is 0.1 normal acetic acid. So from 0.1 normal acetic acid, we have to prepare these 3 solutions. I have already explained to you theoretically how to prepare these solutions. Now I actually demonstrate for you. So half of 0.1 gives you 0.05. So if the concentration becomes half, it's very obvious dilution has to become twice. So what we are going to do is, this is a 100 cm3 standard measuring flask. We have a 25 ml pipette. Now because the total solution is going to be 100 ml, so what am I going to do is, I am going to take only 25 plus 25, that is 50 ml of 0.1 normal acetic acid, and then I will dilute it up to 100. So 50 ml diluted to 100. So that means it is twice the dilution, and therefore half the concentration, which I was talking about, is 0.05. Okay, so here we go. So what we need to do is, first of all, this cannot be directly inserted into it. Alright, so what we do is we transfer some of the acetic acid solution 0.1 normal into this beaker, and then since this is a 25 ml of a pipette, so I have to pipette out twice. So this is the first time. This is 25 ml. You go for the second time. So this comes out to be 50 ml, 50 ml of 0.1 normal acetic acid, which is a weak acid. Alright? Now next what we are going to do is, the best technique is you hold the standard measuring flask to your eye level. Okay, don't keep it over here down and then you're pouring water from the top. No, that's not the right technique. So what we do is you keep it to your eye level, and then this is a conductivity water. As I already mentioned, in the entire experiment we are going to make use of a conductivity water, and then we start the dilution process. Keeping a close watch on the mark. Yes, so this is 100 ml. Now cork it and just make sure that the solution becomes uniform. So you just agitate the solution, mix the solution well. So now what I have done in this is I taken 50 ml of 0.1 normal acetic acid. I diluted to 100 ml. So twice the dilution, so the concentration of this acetic acid becomes 0.05. So what I am going to do is, very slowly I am going to open up this, and this entire solution will go into the beaker, which is labeled with 0.005. Okay, so this is the preparation of the first solution. Okay, I just rinse it this with conductivity water. Make sure that you are using the same standard measuring flask. So if at all there is an instrumental error, then it gets nullified. Now we go for the next preparation of the solution. Which is the next preparation is, you can check it out. It's 0.025. Okay. So now if you can just do a simple mathematics, 0.1 and 0.025. So that means this is 1/4. So that means I have to do 4 times dilution. So 4 times dilution with the total solution is 100 ml. So I guess now you must have calculated, we have to prepare out 25 ml. Because 25 into 4 gives you what? 100. So this time I am going to prepare out only once. Previously I prepared out twice. This time it is only once. So 25 ml I am going to prepare out acetic acid 0.1 normal. Okay, this is 25 ml. And that will be transferred into this same standard measuring flask which we used for the preparation of 0.05. Same procedure again. Now we are going to dilute it with conductivity water, holding this to our eye level. Yes. So you can see it is up to the mark. Close it. Make the solution homogeneous. Now this is 25 diluted to 100. 4 times dilution, so concentration becomes 1/4. And this concentration now of acetic acid will be 0.025. So I will transfer into that respective beaker. Alright. So now we go into the last one now. The last part that we have, and that is going to be about 0.0125. So for this purpose, what we have to do is, we are going to take 12.5. We are going to take how much? Only 12.5. Wash this with some conductivity water. So I will now take a 10 ml pipette. So this is 10 ml. And then finally we have to take 2.5. So this is 2.5. So 10 and 2.5 gives you 12.5. So it is 1/8 of 0.1. That will be the concentration. Because 12.5, if you multiply by 8, it gives you what? 100. Alright? So 8 times dilution. So the concentration will become 1/8, and therefore 0.1, if you divide it by 8, it is going to give you 0.0125. So we are going for the final dilution. Still requires some more amount of water. So as I said, this is going to be 0.0125 normal acetic acid. So that I am going to transfer it into the respective beaker. Alright, so this is the most important step, my dear friends, about dilution of the solutions and preparing the various concentrations from the given 0.1 normal acetic acid. Now the next job is very easy. We need to just take the readings of the solutions by just introducing the electrode as I have shown for KCl, 0.1 normal KCl. Yes, my dear friends, now the most simplest job is we have prepared the solutions. We will now take the reading. It's very simple. Only one thing which you need to remember is, as far as possible, whenever we are preparing different concentration solutions, always start with the lowest concentration. So every now and then there is no requirement of washing the electrode. So we go into the lowest concentration, which you can see it's 0.0125, and you can check out the value also. Simple it is. Just insert the electrode. Of course, one more thing I want to tell you is, it's not necessary you have to take the entire 100 ml solution. Okay, please be very clear. The volume of the solution should be sufficient enough that only this bottom portion, can you see this, the bottom portion, the parallel plates of the electrodes, only that has to dip into the given solution. Okay, but here instead of throwing away the solution and all that stuff, so I kept the entire beaker which I prepared 100 ml. Otherwise, this half of the beaker is also enough. Okay, this is, please you keep this in mind. So you can check the reading now. It is 0.218. Of course, it has to be multiplied with a factor of 10 raised to minus 3 because we are taking it in terms of Siemens. So I will just note down these values, and that value will go over here for 0.0125, and that is 0.218 into the power of 10 raised to minus 3. This is in moles, or we call it as Siemens. Now we go into the next solution after this. We now go into the next solution. This is 0.025. Already you know the procedure. So we are going to just introduce the electrode into it, and you can check this reading. It's 0.318. So I'll just write down over here 0.318 into 10 raised to minus of 3. We have the next solution now, and that is going to be 0.05, and you can check the reading. It's 0.434 into 10 raised to minus 3. So finally now we go into 0.1. What is this 0.1 is? Actually whatever the acetic acid that has been given to us. Okay, that value, that solution we are going to take, and we are going to note down the reading, and this is 0.559. So I write down over here 0.559 into 10 raised to minus of 3. Right, so that is it, my dear friends. The concentration values, the conductance value, the specific conductance at 25 degrees Celsius is from the literature value is the same one, that is 12.88. The conductance of KCl also I showed it is 12.88. So if we are going to divide this, we get the answer as cell constant will be equal to 1. Okay, and these are the values. Next I will show you the calculations. Okay, my dear friends, now we go into the last part, and that is about the calculations. So you can see here we start with cell constant. That was the first part of the procedure. Specific conductance upon observed conductance. From the literature value, it is 12.88 into 10 raised to minus of 3. When we observe the conductance of KCl, it was also 12.88, and therefore the answer is 1. So cell constant value is 1. And I told you, if the cell constant value is provided, so use that value, no need to do this calculation. Okay? Next is equivalent conductance at infinite dilution for acetic acid and that is 390.7 moles Cm square equivalent -1. ये वैल्यू ऑलरेडी दिया हुआ है आपको. इनफाइनाइट डाइल्यूशन. नाउ व्हाट इज द मीनिंग ऑफ इनफाइनाइट डाइल्यूशन? दोस्तों अगर आपको याद है, मैंने जब प्रोसीजर आपको बताया था तो स्टॉक सोल्यूशन हमारा क्या था 0.1 नॉर्मल एसिटिक एसिड. उसमें से हमने उसको डाइल्यूट किया और ये सारे कॉन्सेंट्रेशंस बनाए. तो डाइल्यूशन की वजह से देयर वाज अ चेंज इन द कॉन्सेंट्रेशन. But then here when I talk about infinite dilution means that I am diluting a solution or a substance to such a great extent that beyond which if I am going to add water into it, there is going to be hardly any effect on the concentration. इसे हम लोग बोलते हैं infinite dilution. And it's dilution to such a large extent कि उसमें पानी डालने के बाद concentration के ऊपर उसका कोई असर होगा नहीं, और अगर होगा भी तो it is very very negligible. Okay, that is what is infinite dilution is. और ये वैल्यू आपको दिया है. अभी बात करेंगे ऑब्जर्वेशन टेबल के बारे में. द फर्स्ट कॉलम इज कॉन्सेंट्रेशन फॉर सॉल्यूशंस. 0.1 वाज SS दैट इज स्टॉक सॉल्यूशन. उसमें से मैंने 0.5 बनाया, 50 लेके 100 तक डाइल्यूट किया. फिर मैंने 0.025, सॉरी दिस इज 0.05 नॉट 0.5, 0.05. फिर 0.025 के लिए मैंने क्या किया 25 लेके 100 तक डाइल्यूट किया. And then we went into 0.0125, 12.5 लेके 100 तक डाइल्यूट किया. हमने कंडक्टेंस वैल्यू नोट किया, आप लोग ने ऑलरेडी देखा होगा वो. ओके, सो दीज आर ऑल द कंडक्टेंस वैल्यूज. स्पेसिफिक कंडक्टेंस के लिए द फॉर्मूला इज कि जो कंडक्टेंस है उसको मल्टीप्लाई किया विद सेल कांस्टेंट. अब क्योंकि मैंने सेल कांस्टेंट ऑलरेडी कैलकुलेट करके दिया है, दैट इज 1, यानी जो वैल्यूज इधर होगा कंडक्टेंस के लिए सेम वैल्यू इधर कॉपी करना. Okay, so this will be specific conductance. क्योंकि any number multiplied by 1 gives you the same number. अब आएंगे यहाँ पर. Okay, that is equivalent conductance at a particular concentration. तो उसका फॉर्मूला है 1000 K/C. K मतलब specific conductance और ये C मतलब कौन सा है concentration. तो क्या करना है देखो दोस्तों. आप बोलोगे सर ये 10⁻³ क्यों ऐसा अलग से रखा आपने, 0.00 क्यों नहीं किया? क्योंकि उसका रीजन है कि ये 10⁻³ और ये 1000 कैंसिल हो जाएगा. ओके, तो बचेगा क्या 0.559. उसको फिर कॉन्सेंट्रेशन से डिवाइड करो, 0.1 से डिवाइड करो, तो आपको क्या मिलेगा 5.59. ओके, दिस विल बी इक्विवेलेंट कंडक्टेंस एट अ पर्टिकुलर कॉन्सेंट्रेशन. ठीक है. अभी कोलास लॉ शायद नाम सुना होगा आप लोग. ओके, कोलास लॉ के हिसाब से the degree of dissociation is the equivalent conductance at a particular concentration to the equivalent conductance at infinite dilution. हमने ऑलरेडी equivalent conductance at a particular concentration फाइंड आउट किया है, तो उसको डिवाइड करना है विद 390.7. तो उसको डिवाइड करेंगे इसको 390.7 से, तो क्या मिलेगा हमें 0.0143. और एक बार ये डिग्री ऑफ डिसोसिएशन पता चला, ओके, दैट इज अल्फा का वैल्यू पता चला, जैसे आपको मैंने बोला है इट्स नॉट एक्जैक्टली 0 बट इट इज क्लोज टू 0 क्योंकि वीक इलेक्ट्रोलाइट है. मैंने आपको पहले ही बोला था इन द थियोरी पार्ट ओके ऑफ दिस पर्टिकुलर एक्सपेरिमेंट. अभी क्या करना है, अल्फा का वैल्यू अगर मिल गया हमें, देन फाइनली ओस्टवाल्ड डाइल्यूशन लॉ का एक्सप्रेशन है K = α² C/1 - अल्फा. तो कैसे करेंगे? अगर आपको कैलकुलेटर से करना है तो मैं आपको ट्रिक बता देता हूँ. पहले जो अल्फा का वैल्यू मिला उसको स्क्वायर करो, मल्टीप्लाई बाई C मतलब कॉन्सेंट्रेशन. ओके, मल्टीप्लाई बाय C मीन्स कॉन्सेंट्रेशन. मैं क्या करता हूं, आई राइट इट डाउन एज कैपिटल C. ओके, दिस इज कैपिटल C, ये स्मॉल c. तो वो आपको है ना टेंशन नहीं रहेगा कि ये कॉन्सेंट्रेशन वाला C है या कंडक्टेंस वाला C है. सो α² C. सो व्हाट वी डू इज दैट 0.0143 आई एम गेटिंग, राइट, दैट इज अल्फा. उसका स्क्वायर करो, मल्टीप्लाई बाय 0.1 डिवाइडेड बाय, अभी साइंटिफिक कैलकुलेटर यूज कीजिएगा. ओके, डिवाइडेड बाय, फिर ब्रैकेट होता है वहां पर. ओके, इन अ साइंटिफिक कैलकुलेटर देयर इज अ ब्रैकेट. सो प्रेस ब्रैकेट 1 माइनस ऑफ 0.0143 एंड देन इक्वल टू प्रेस कीजिए, यू गेट द आंसर. वापस से बोलता हूं 0.0143 ये अल्फा का वैल्यू है. तो साइंटिफिक कैलकुलेटर यूज करना है, तो साइंटिफिक कैलकुलेटर में एक बटन है x², तो उसको प्रेस करो तो उसका स्क्वायर हो जाएगा, मल्टीप्लाई बाय 0.1. ओके, वो करो, इक्वल टू आएगा, डिवाइडेड बाय ब्रैकेट, ओपनिंग ब्रैकेट वाला. ओके, ओपनिंग ब्रैकेट ऐसा वो प्रेस करो, और प्रेस करने के बाद क्या करो 1 माइनस 0.0143 और फिर इक्वल टू प्रेस करो. आपको ये वैल्यू आ जाएगी। यानी आपको अलग से कहीं पर कोई वैल्यू लिखने की जरूरत नहीं है, पूरा एक ही साथ पूरा कैलकुलेशन हो जाएगा। ओके, कोई लोग क्या करते हैं, पहले अल्फा को स्क्वायर करेंगे, फिर कॉन्स्टेंट, फिर वो वैल्यू लिख देंगे, फिर वो 1 माइनस ऑफ अल्फा कैलकुलेट करेंगे, 1 माइनस ऑफ दिस, ओके, वो वैल्यू लिखेंगे, फिर वो वैल्यू को उससे डिवाइड करेंगे। इतना सब मगजमारी नहीं करना है। ओके, ये जो मैंने आपको टेक्निक बताया वैसे करो, ओके, तो आपको फाइनल आंसर मिल जाएगा। सो दिस इज 2.07 into 10⁻⁵ समझा आप लोग को? दिस इज द वे द कैलकुलेशन हैज टू बी डन। पहला ये पार्ट पूरा कॉपी पेस्ट, फिर ये वैल्यू को कॉन्सेंट्रेशन से डिवाइड करो, 10⁻³ और 1000 कैंसिल हो जाएगा तो ये मिलेगा। उसको फिर 390.7 से डिवाइड करो तो आपको अल्फा मिलेगा, और फिर मैंने आपको टेक्निक बताया उससे कि ये फाइंड आउट करो। वैसे सब जगह एवरीवेयर यू आर गोइंग टू डू द सेम। अब ये कंडक्टेंस वैल्यू है, सेम कॉपी पेस्ट, तो अभी ये वैल्यू को 0.05 से डिवाइड करेंगे तो 8.68 मिलेगा। फिर 8.68 को 390.7 से डिवाइड करो तो आपको ये मिलेगा 0.0222, और फिर मैंने जो टेक्निक बताया उससे 2.52, एंड दिस वे यू कैन कंटिन्यू फॉर द नेक्स्ट ऑल्सो। फिर ये चारों वैल्यू को ऐड करो एंड यू डिवाइड इट बाई 4 तो आपको ये मीन मिलेगा। ओके, अब देखिए द मोस्ट इंपॉर्टेंट पार्ट इज द कंक्लूजन। अब ये सारे वैल्यूज देखेंगे तो आपको पता चलेगा द वैल्यूज आर ऑलमोस्ट कांस्टेंट, ओके, और फेयरली कांस्टेंट। सो मैं यहां पे लिखूंगा सिंस द वैल्यूज ऑफ Ka फॉर वेरियस concentrations are fairly, not exactly same they are, so they are fairly constant, and therefore ODL is verified. याद है ना, मैंने आपको थियोरी के बारे में बताया था कैसे वेरिफिकेशन करना है, K का वैल्यू फाइंड आउट करना है फॉर वेरियस कॉन्सेंट्रेशन, एंड देन वी हैव टू प्रूव दैट इट इज ऑलमोस्ट कांस्टेंट एंड देयरफॉर इट इज वेरीफाइड। ओके, बहुत लोग बोलते हैं सर इधर तो डिफरेंस है, 2.07 है, 2.52 है, 2.74 है, 2.60, लेकिन ये तो देखो, प्लीज कॉन्सेंट्रेट ऑन दिस ऑल्सो, 10⁻⁵ है वो, 0.00002 समथिंग। ओके, तो वो भी ध्यान देना है। आप सिर्फ इसको ही ध्यान देते हैं और फिर बोलते सर ये तो काफी चेंज हो रहा है, लेकिन इट इज इन 10⁻⁵, एंड देयरफॉर वी से इट्स वैल्यू इज व्हाट, फेयरली कांस्टेंट, एंड देयरफॉर the Ostwald dilution law is verified. All right. So this is, my dear friends, the entire experiment. Okay. In the first part, I had explained you about the theory behind this experiment. Okay, and then I explained you theoretically the procedure behind this particular experiment. Okay, and in this part, I practically demonstrated in the laboratory how this experiment is to be carried out with respect to all the procedures, and after that, I have shown you this calculation. So I hope you have understood this very well. Thank you very much for watching this video.